we are discussing GATE BM 2022 paper, and objective of this session is to verify the key that has, that is out very recently. So first thing is, yeah, the paper appears easy, but it's full of traps. Even the committee seems to be falling for the traps in the paper. So we want to spend the next 3 hours discussing on, in fact, verifying the key that has been given by the committee. Okay, we'll try to do that as soon as possible. Objective of this session is not to solve the paper entirely and all that, but wherever the question needs some time, demand some respect, will certainly stay there and spend some time, and we'll verify the key for most of the questions by the time you are done with this. Okay, so that's the objective of this session. Let's get quickly started. This is too high for it to be considered. I think the FAIR is too high to be considered FAIR. So I think this is very, very common to give homonyms in GA part. Right, this occurs very, very frequently. Okay, here the function y of x defined in the interval on the axis, on the x-axis as, okay, y is, it's a constant, okay, 2 at some interval, 3 at some interval, 1 at some interval. So if one were to draw it, okay, so we have 0, 1, okay, and then we have minus 1/3 somewhere over here, or 1/3 somewhere over here, and then 3/4 somewhere over here. Okay, so it is 2 here, and then in this interval it is 3, and then in this interval it is 1. So just the 3 areas, I suppose you could easily find that. In this case, I think the key matches properly. Okay, so let me quickly leave a note on this. This is 2 into this area, that is 1/3, this rectangle plus this rectangle, that is 3 into 3/4 minus 1/3, and finally other rectangle, that is 1 into 1 minus 3/4. Suppose, what do you get here? This is 13/6, I suppose. Okay, another easy question. So I think we can proceed next. Okay, let R be a root of the equation x squared plus 2x plus 6 is 0. Then the value of the expression is this. Yeah, again, an easy question. Notice we have seen this again and again and again in terms of Cayley-Hamilton, right? Finding some powers of matrix. In this case, instead of check all that Cayley-Hamilton, just it's a root of the equation. So R satisfies this, R square plus 2R plus 6 equals 0. Can you just find a higher order power of R? So I think this can be quickly simplified. This, I suppose, is R square plus 5R plus 6, and this is R square plus 9R plus 20. Okay, so this is, notice this term is 0 here. So what we are left with is 3R, and what we are left with is 7R plus 14. Okay, so that makes R plus 14. 1 second. Yeah, again, this is R square, few things down the line. If you take the R common, this is 3 into 7 into R square plus 2R. So this term is minus 6, so it comes to minus 126. Okay, another standard question. We have seen this again and again and again, so not an issue here. So given below are four statements. All students are inquisitive. Some students are inquisitive. No student is inquisitive. Some students are not inquisitive. So I think, okay. Find the two statements that cannot be true simultaneously. Always, it's a good idea to deal with this using Venn diagrams. So I'm going to draw a square for inquisitive and circle for students. Okay, so all students are inquisitive. So all the students are over here. Okay, some students are inquisitive. So this thing kind of intersects like this. No student is inquisitive. So this this is like this, and some students are not inquisitive. Again, this is something like this. So actually 2 and 4 can match. Okay, but 1 and 3, there is no way things are going to match. All the students are inside, all the students are outside. That cannot be possible. So statements 1 and 3, again, there is no issue with that question. So palindrome is a word that reads the same forwards, backwards. Okay, we are given player has 2 letters. Okay, for the additional plates given in the option, which one of the combination of additional plates will allow the player to construct a 5-letter palindrome? So palindrome is something that reads both the ways. So we have AD. Idea is to, can we use any of these and make a quick, palindrome here? Technically speaking, you should be, you have to do this logically. It's a palindrome, it's a 5-letter word. So it can be, AD here, DA here, and then AD, and then DA. So that, things should repeat here and here. There should be a D here and so on. Then pick whatever fits there. But, in this question, if you just notice, quickly recognize that, radar is the word. Yeah, if you just notice, the palindrome here that can be quickly formed is radar, you can just, go ahead and I suppose a rotation of plates is allowed. So, if you rotate this, you get that. But if you take this approach, notice it's going to take some time. So if you're fortunate to recognize a palindrome radar, using the letters given here, that is very good. Then some people believe what measures text inference. So what can be logically inferred here? I think this is also fairly straightforward. Okay. What gets measured, improve. Some others believe what gets measured gets gamed. Okay, so there are two different beliefs. For the difference in beliefs is perhaps possible reasons. So perhaps work culture and organizations. Good work culture, metrics help improve outcomes. Same metrics are counterproductive in organization with bad culture. So metrics are useful in organizations with poor work culture, not necessarily. Metrics are useful in organization with good work culture. Again, not the so. Where is the statement over here? Yeah, poor thing. I think this is counterproductive. Okay, so this is not possible. Good work culture, metrics are useful. Always counterproductive. This is, of course, strong statement. Hints strongly suggest it's incorrect. And then metrics are never useful in organizations with never. Again, a very strong statement doesn't fit. Okay, so B makes best sense. Then recently conducted national entrance test, boys constituted 65% of those who appeared for the test. Girls constituted remaining candidates that they accounted for 60% of the qualified candidates. Okay, so we have essentially two pie charts. This has appeared. Okay, and 65% boys, so rest 35% is girl. And then here we have, so qualified is a small part of that. And in that, I suppose we have girls constituted the remaining, and they accounted for 60% of the qualified candidates. Okay, so what we have here is again a ratio like this. So among the qualified, 60% are girl and 40% are boys. This is just if you look at those who qualified, and this is if you look at who are up here. Equal number of boys and girls qualified. Let me label this. Let me label this 1. Let me label this 2. Qualified, 2 says this is incorrect. Equal number of boys and girls appeared for the test. 1 says this is incorrect. Number of boys who appeared for the test is less than the number of boys, girls who appeared. Again, 1 says this is incorrect. Number of boys who qualified in the test is less than number of boys or number of girls who qualified. So here, of course, D says this is correct. So again, not an issue with the key, I suppose. So wherever you think there is an issue, just stop it. Box contains 5 balls of same size. Okay, this is drawing. So 3 of them are green, and then we have 2 of them are orange. Okay, balls are drawn from one box, from the box one at a time. If green is drawn, it's not replaced. Orange is drawn, it's replaced. So there are 2 possibilities, green and orange. If green is drawn, what we are left with is 2G 2O. Green ball is not replaced. If orange is drawn, we are still left with 3G 2O. Okay, what we want is first ball is drawn. What is the probability of getting an orange ball in the next draw? Here we want an orange, here we want an orange. Okay, or this. 2 cases. So this is, notice you have to first pick a green, that is 3/5 into then an orange 2/4, or so that's a plus, and then we have 2/5 into 2/5. Okay. Again, if you quickly calculate what this boils down to, I suppose this is 23/50. Okay, just calculate this fraction. This should come out to 23/50. So not an issue there too. I'm actually waiting for some question that is interesting. Okay, so there you have it. Corners and midpoints of the sides of a triangle are named using distinct letters P, Q, or S, T, but not necessarily in the same order. Consider the following statements. Line joining PR is parallel to line joining QS. Okay, P is placed on the opposite side opposite to the corner. S and U cannot be placed on the same side. Anyone managed to get this question correct in the exam? Anyone here? Okay, this is hard. Yeah, we'll get to that. I think the answer key says it's B, and I also think this is correct. Okay, but this question is hard. Usually they are seating arrangement, right? Compared to that, this statement means lots and lots of cases. Okay, so PR QS. Notice this two could be parallel. It can be RP QS. Technically RP QS, and then even if you mirror this RP SQ, it's a different triangle. Okay, there is nothing mentioned about things. So even if you mirror this, you get a new triangle. And not just this. So PR and RP need not be in this way. So you can have PR and then you can have QS. So each of them has individual cases blowing up. And to make things work, this is not the end of the thing. You have cases like this. Okay, PR, this is like some, I think this Doctor Strange Multiverse of Madness movie is coming. So I don't know how many of you saw this, at least Loki or something like that. Perhaps you're busy preparing for GATE. You may not have time. So even this case is now starting to get possible. Still finite number of cases, but it goes on and on. So lots of cases to enumerate. And yeah, I couldn't think of a simple way to list all of these out. Okay. But here let's focus on our objective. Can we verify? This is the key. Can we verify that? Yes, I did find two triangles, that two cases that satisfy all the three conditions. One of them is U, okay, P, R, and then Q, S, T. Okay. Notice PR is parallel to QS, P is placed on the side opposite to T, and then S and U not on the same side. Okay, S in this side, U in the other two sides. So this case is possible. There is also one more case that is possible. Okay, T, Q, S, and then we have P, U, R. This case is also possible. Okay, there could be many other possibilities, which is what I was meaning by, the list goes on and on, but I have shown two possibilities that satisfy these two conditions. Notice here, PR is of course parallel to QS, P is opposite to, on the side opposite to T, this side is opposite to corner T. So it doesn't say that it's strictly in the midpoint opposite to T. Okay, and S and U are placed on not placed on the same side. S and U are on different sides. So this is case 2. Many more cases are possible, but here, see if we can disprove any of the statements. If any of these two cases serves as a counter example to this. P cannot be placed at a corner. Case 2, P is at the corner. So this is not correct. There is a counter example just right over here. Okay. So this is case 1. S cannot be placed at a corner. At least are the two examples that I have shown. S is not at the corner. It's at the midpoint. Okay. U cannot be placed at a corner. Let's make sure these two options are incorrect. U cannot be placed at a midpoint. Again, case 2, we have a nice counter example. Or cannot be placed at a corner. Again, we have a counter example in case 1. So not correct. At least, we can write down two possible cases. I have listed them here, where we can rule out options A, C, D. That leaves only option yes. Okay. So key makes sense. Notice more cases are possible. But here we can answer the question. More cases are possible. Is there a nice systematic way to write down all this, list down all these things? Yeah, it's going to take a lot of time. If you find anything simpler, any of you, let me know. Okay. So plot of land must be divided between 4 families. They want their individual plots to be similar in shape, but not necessarily equal in area. So with what kind of a family actually is okay with, shape, and doesn't matter about area. Okay, anyways, let's get to this question. So any of you, it's perhaps the symmetry line somewhere over here. You're trying to draw this, trying to make shapes in the exam. I knew just the moment you came out of the exam or when you saw the question paper, again, you realize there is a simple way to connect things, right? So all the shapes are similar, and then you need 1, 2, and 3 ropes. But without those 3, yeah, you're trying all sorts of polygons here, that shape that is same. Okay. I'm glad if you managed to get it in the exam, but I can anticipate many students getting confused about this during the exam. But the answer is simple. A rope here, and a rope here. Okay. Fine. So 3, I suppose that also is the answer key. Kelly Hamilton. So they gave a question in roots, and they also gave it in this thing. This is, I think, straightforward. Right. So I suppose everyone here did manage to get it in the exam. So 3 minus lambda minus 2, 4, minus 2 minus lambda. Determinant of this is 0. So we have lambda minus 3 into lambda plus 2 minus of this thing. I suppose minus of minus is 8. Right? Yeah, that's a plus 8 equals 0. So we have lambda square minus 3 lambda plus 2 lambda, that's minus lambda. Then we have a minus 6 plus 8 is 0. So we have lambda square is lambda minus 2. That means a square is a minus 2i. That means this term k is 1. And pretty straightforward question, expected. So not really an issue there. Evaluation of the integral. So here again, it would be nice, any of you manage to get this right in the exam. Afterwards, of course, you look at it, you could get it. That is nice. Yeah, if you manage to get it right in the exam, that is good. It's also easy question. All you have to do is, remember the standard integrals. That is a mistake I anticipate most students would have done. Inability to recollect all this integrals that we studied in high school and all that. Perhaps we tried for JEE, AEEE and all that. So verification, again, some might be confused about differentiating sine inverse x, right? Sine cos. So there is it's a double-edged sword. This side, if you take the root, you have to do this integral. This side, if you take the root, okay, you have to do the differentiation. So you have to recall either this or that. Okay. The point is this dx root of 1 minus x square is sine inverse x. If you notice this, yeah, with some practice, you quickly recognize if you complete the square, you essentially have this integral over here in a slightly different form. If you add plus and minus 1, okay. Mathematicians or people who practice a lot do this instantaneously, but others are wondering, why did you add plus and minus 1? Okay, so this certainly comes with practice. 2x minus x square, that's it. This term is x minus 1 whole square or minus of that. Okay, so dx into 1 minus x minus 1 whole square. So notice, so this is sine inverse of x minus 1. So this is again is correct, not an issue. Okay, now they are actually throwing away marks at you. We kind of set a lot of traps. Now at least get few marks here. Okay, this question looks like that. You are given a vector and you want to find the invalid operation. Okay, so curl of a vector will be a vector. You can take divergence of that. Divergence of a vector is a scalar. You cannot do curl of that. You can only do curl of a vector. Okay, invalid. Okay, divergence of V is a scalar. You cannot do curl of that. Divergence of V, this is a scalar. You can take gradient of a scalar, no issue. You can take, gradient of V is vector. You can do curl of that. Again, not an issue. Okay, none more interesting question. So, okay, now things are starting to get interesting. So xt is a real continuous time signal whose magnitude frequency response x of j omega. Notice this is magnitude frequency response. Okay, what they are saying is I am setting a trap. If I give you frequency response, you know how to do this. So we are going to give you magnitude frequency response. After sampling x of t at 100 rads per second, spectral point P is down converted to in the spectrum of the sample signal. How many of you chose 12.5? I suppose the answer key is 37.5. Quickly, how many of you want to challenge or explain key? This is the key. I suppose these two are not there, not candidates for contention. At least 12.5 is a trap or makes sense. So there are two ways to do this. You could take a mathematical approach. You could also use a visual approach. You have to be careful taking the mathematical approach when there is modulus. Okay, I'm going to show the visual approach. If you're looking at magnitudes of the spectrum, you don't worry about signs. The way this transform happens is the function that maps any given signal, okay, f input. This is f downsample signal, f output. That function looks like this. Till the sampling frequency 50, it goes straight. So until here, notice input is equal to output. Okay, 20 radians per second, it's 20 radians per second. This is a 45-degree line. Had it been, they didn't give the magnitude, the curve this is supposed to go is start at a negative here and go like this function, like a sawtooth. But what is given is a magnitude. So what happens in that case is the actual function looks like this. So when you take modulus of this, it becomes like this. And again, this becomes like this. Of course, this is at 50. This is at 150. Notice 162.5. Okay, signal here gets mapped to something close to 50. Specifically, that value here is 37.5. Okay, so 150 gets maps to 150. Slightly move away, it's going to decrease from 150. And notice this is a linear change. So if you move 12.5, it's going to decrease by 12.5. So it gets maps to 35. See, on the other hand, a point here, 150 plus something like plus 37.5. That point will be here. That will get mapped to, interestingly, this value, which is 12.5. So in this case, the key is correct. And you're looking at the magnitude spectrum. So the actual mapping between this input signal frequency and the downsampled signal frequency is this sawtooth. You could also do this mathematically, but I always find this version convenient. So okay, I suppose that's a key. Discrete signals x of n, y of n are shown below. Cross correlation or xy is 0. Any of you tried this question? I had issues with this question. Okay, let me quickly do what I know as cross correlation, and this is the 0th term. That is, take this function, take this function without any delay, multiply and add. Okay, that is the definition of cross correlation that I know of. Let's quickly do this. 0, 1, 2, 3, 4, 5, 6, 7. These are indices. We have x of n. Okay, notice start at 1. We get to 1 over root 2. Then we get to 0. Then this is minus 1 over root 2. Then this is minus 1. And this is minus 1 over root 2, 0, and 1 over root 2. So just product of this and this, and these signals are also real. So you don't have any issue there. You don't even have to take any conjugates or things like that. So delay is 0. So take the signal right as such. This signal is 1 over root 2, 0, minus 1 over root 2, minus 1, minus 1 over root 2, 0, 1 over root 2, and 1. Cross correlation, just this into this, especially we are talking about or xy of 0, this into this, plus this into this, plus this into this, plus this into this. So the 0, we didn't put any delay here. So that is actually says we are looking at 0. So the product of this and this is, 1 into 1 by root 2. This 1 by root 2 into 0 is 0. 0 into minus 1 by root 2 is 0. This is plus 1 by root 2. Okay, and this also I suppose is plus 1 by root 2. This is 0. This is 0. And this is 1 by root 2. So all of them are positive. This is 4 by root 2, that is 2 root 2. Is that the answer key? At least this we should be able to do. Okay, I expect some help from the other side with, I mean, what if, if we don't get the answer key, we should raise an issue. Answer key says B. Okay, key. Again, I look for traps and all that. This is cross correlation, no normalized cross correlation, nothing like that. And certainly this is the cross correlation, just, product of these two, sum of products. And I think this should be contended. Okay. This should be challenged. That's my call based on whatever I know about cross correlation. So again, none of you are raising an issue. And at this junction, let me also say what happens. There are 3 possibilities during challenging an answer key. One is incorrect. Okay, you tell them, no, you made a mistake. See, you fell for the trap that you set for the students. You say to the committee. The committee, somewhat, this is very, very objective. So committee will certainly correct their mistake. They will correct the key specifically, which is when they release the final key. Final key, they will correct it. There is a mistake, of course, they will correct it. Okay, this is the first possibility. This question kind of falls in that case. Okay. Then questions could be ambiguous or framed poorly. Here, you need to be like a, lawyer. You should make your point crisp and like hitting a nail in the forehead. Okay, because it's very hard for usually gate committee to convince them that they are wrong when things are somewhat subjective. This is objective. Answer is anyone can verify anytime. Somewhat subjective, things are ambiguous. It's very hard to convince them. Okay, you have to write a nice challenge letter that that's very concise, very crisp, makes the point very clear. There is a possibility of getting an MTA. Okay, possibility of MTA. But you have to write a nice challenge letter. I'll also show examples of this somewhat later down the line. Third thing is out of syllabus. They will say basics of transfer function. And they will ask you non-unity steady state error. Okay, because that's also basics of transfer function according to the gate committee. Once they give a, whether they looked at the syllabus or not, they set a question, that's it, it's there in the paper. So out of syllabus does not hold water. This comes from last year's experience. Okay, no point challenging. Save money in this case. Okay. So these two, if any one challenges it, the key will be corrected for everyone. Okay. To have a nice discussion, just one of you write a nice, nice challenge, send it to them. Okay. Then hope that they acknowledge the issue. And this, don't waste money. Even if you crowdsource as a group, you raise 500 to raise a challenge, don't do that. Out of syllabus and all, they really don't care. So which brings us So this question should be challenged, and answer is 2 root 2 according to me, and I think it will be corrected. So let's go to question 16. So we have issue with SR latch. They gave a SR latch with non-gates, and then that has a X NOR gate, and the question is not combinatorial, or the question is not just sequential, but something to do with propagation delay. Yeah, when is a pulse with 1 volt? So given propagation delays, input to output delays of 200 picoseconds and 400 picoseconds. Anyone managed to get this during the exam, or at least after the exam? The key says 200 picoseconds. Okay. I did get this key. Okay, the explanation is going to be slightly tricky for us to handle now. So at least I'll point you what they are doing, what they are essentially asking. This is hard. In fact, I haven't seen a hard question like this even in electronics paper. Okay. I have seen many PYQs, but nothing hard like this. I have seen lots of questions from using propagation delays and all that. They will put a mux combinatorial circuits propagation delay kind of easy, but you have to do both combination as well as sequential with the delay, so it's somewhat challenging. First, there is a input A and a input Y. There is some stable input Y. This is a NAND SR latch. Okay. So when you change input A, after 200 picoseconds, your X is going to change. Again, you also change B at the same time, so your Y will also change. Okay. So A is this. B. So this is 0, this is 1. B is this, right? This is 2T. So when this change happens, let's mark this as some kind of a milestone. So plus 200 picoseconds, X and Y will change. X and Y will change. Okay. And when X and Y change, notice they are fed back into the system. So plus another 200 picoseconds, X and Y will change again. Change again. This is the operation of the NAND gate. And then here, if you have, ideally speaking, if you use this as a memory, this thing one is 1, 1 is 0. These are complements of each other. But in this minor thing, if it so happens that both X and Y can be 1, okay, such a state occurs here. It can happen here or here. I suppose it happens here. Okay. After 400 seconds, picoseconds, your Z will change. Okay, and this state will essentially remain so till 200 picoseconds. Okay, there is a X is 1, Y is 1 state here at the start. That will make your Z1 change to 1 for a very short duration. So, and that duration is essentially this 200 picoseconds, just that it happens with a delay of 400 picoseconds, but the duration will be the same 200 picoseconds, during which X and Y will both be 1, even in this SR latch. Okay. So answer 200 makes sense. So, later I'll discuss full solutions for this. I'll give the, proper timing diagram for that. I have it right now, but, I will just digress from our original thing. If you're slightly curious, so let's just extend this. Let me draw what I have. So everyone in YouTube, sir, can you discuss the solution? So this is X, Y, Z. And then when we actually discuss the solution, for some reason, they don't show up. Okay, so this gap is 200 picoseconds, and your Y essentially 0 till this point. Okay, here it's a very critical thing. X will be 1, Y will be 1 for again 200 picoseconds. And then X gets back to 0 because of the logic there, and then Y remains this. So this is a critical window. This is 200 picoseconds. Okay. The effect of this will be seen 400 picoseconds from here. 400 picoseconds from here. Okay, which is when momentarily Z will become 1, remain 1 for this length. When both X and Y are 1, then it goes to 0. Yeah, why this is like this, why this is like this, we'll discuss later, but at least this is a timing diagram, and here Z is 1. Z is 0, 0, 0 here. And this is actually technically, from a functional point of view, this is a mistake. And that's also very important from a, design perspective. Okay. So this is somewhat easy compared to this question. This is a fairly straightforward digital logic question. At least if you know what is what, you should be able to answer this. You have XY, and then you have, this is sum carry sum. Even if you don't know a lot of things, sum is 0 plus 0 is 0, 1 plus 1 is 1, 1, and 1 plus 1 is 10. So sum is 0, carry is 1. Okay. So now somehow using this, we should get this. Notice S is actually XOR. Yes is X dash Y or X Y dash. Okay, let's look at what comes here. What comes here is product of all these three. D1, X bar, Y bar. We don't need this term. Okay, we don't need this term. So D1 should be 0. What comes here is D3, X bar, and is this X bar here also? No, here what comes is Y. X3, Y comes here. Okay, so this here, we need this term because this term is there. We want that coefficient to be 1. So D3 is 1. And then what comes here is D0, X, and Y bar. D0, X, Y bar. We also need this term because, we need this term. So we don't want to make D0 0. So D0 is 1. And what comes here finally is D2, X, Y. We don't need this term. So make D2 0. So that gives us 1, 0, 0, 1. Okay, so that's also correct. Okay, so one more question. So I had some poll in YouTube, and so this is one place, it says majority need not be right. Okay, so most about 60% voted for 300 pi by 360. Official key is C. A strong contender here is 10 by 360. So quickly, what would be the answer here? Actually, this question is I would have tried to, argue for ambiguity in the question, but they have deliberately set traps. This is a trap. This is an obvious trap. That is, okay, you look at 60-degree phase difference, perhaps, 3 by 300 by 360, something like that you do. This is like a somewhat an obvious trap. It's also a trap. This is a very, very actually a clever trap. They have intentionally set this trap. So I'm not going to say they meant this, there is any ambiguity here. The answer key makes sense to me. Best way to look at this is as a phasor diagram. Okay, in the complex plane, we have real part, imaginary part. Notice in the real direction, this corresponds to cos omega t. Okay, we measure angle, positive angle this way. Okay, positive time. Okay, any angles positive this way. And this corresponds to imaginary part, specifically, negative imaginary axis. So complex plane is this. This is sine this direction corresponds to sine omega t. Notice sine and cos has a 90-degree phase shift. Even if you don't remember trigonometric identities, you could say actually take cos, put a minus 90-degree phase, you get a sine. Okay, you could look at this. So what is given as 2 cos this phasor somewhere over here. So one is, I think, 2, another one is 3. Okay, this is corresponds to 2 cos at an angle of 60 degrees. There is one more phasor. I'll have to, or there is a slightly better way. There is one more phasor in this direction. Notice it's at minus sine omega t direction. Okay, magnitude is slightly larger. This actually corresponds to minus sine omega t. So what they are asking us, notice 2 pi corresponds to a time period, omega times t. So if you know this fraction of angle between the two phasors, you essentially know that you can calculate the time taken. Okay, question is, we have 2 fractions, option 1, option 2. Should we use this angle between this phasor and this phasor, or should we use this angle between this phasor and sine omega t direction? So quickly, what do you think should we do? Anyone has preferences over 1 or 2? And let me also say that I think if you use 1, answer is B. If you use 2, answer is C. So notice, if you were to use 1, you are looking at distance between. So at this point, a thing has a negative peak. It is minus 3. So this phasor is minus 3. After, after some time, omega into this angle corresponding to this angle, cos hits a peak. Okay. So should we look at distance between, delay between positive and positive peak, negative, or positive and negative peak? That's a question you have to ask. Okay. So even though the first phasor minus 3 sine 60 is over here, the positive peak for that will happen along this vector, along this angle. So the positive peak is over here. The distance between this positive peak to this positive peak should be this angle too. That is very easy to do. This is 60, this is 90. So that is 150 degrees divided by 360 degrees, and you do into 2 pi by omega. Okay, that is essentially I'm doing t corresponds to 2 pi by omega. This is time period. So now this is the time taken to traverse the entire circle 360 degrees. What is the time taken to traverse part of it? That is okay, 150 degrees corresponds to how much time? Okay, that simple ratio is over here, and this happens to be 50 pi by 360. Okay, so this is somewhat tricky, and so the positive peak happens here, and yeah, so whenever this has a positive peak, after this much time this should have a positive peak, so the delay should be 50 pi 360. If you are looking at distance between negative and a positive peak, because peaks doesn't specify positive or negative, you could 10 pi by 360 can be an answer. I don't think it's worth arguing here. Okay, even though this peaks is precisely not correct, I don't think they will accept it. And the trap seems to be deliberate. That reinforces my guess that they won't accept a challenge here. So the key here makes sense. I suppose it's C. Yeah, I suppose it's C. So let's move on. For the balanced oven bridge circuit shown in the figure, values of Lx, Rx, or okay, actually this is one of the simplest questions. So in this case, if you consider this as Z1, Z3, Z2, Zx, you have impedance Z1 by Z3 as Z2 by Zx. If you just do the math properly, in simple ways without doing a lot of complex multiplications, I think you should get the answer easily. I hope all of you here can write down the impedances. So I'm not going to write this. This is R3 plus 1 by j omega C3. This is Rx plus j omega Lx. This is R2. This is 1 by j omega C1. So if you do that, what do you get? I suppose B. I did get B. That's the key. So not an issue there as well. Okay, myopia occurs when the focal point falls dash in the retina. This can be corrected using. So again, this is some sort of high school biology questions kind of showing up. But let me quickly tell you, see, you know what myopia is? Your vision is myopic, used quite often. So myopic vision, short-sightedness. If you know that, can you somehow logically guess, should it be in front of, should it be behind? Is there a way to guess it? Not guess, actually, to predict it reasonably well. Not blind guessing, actually a very, very educated guess. Is that possible here? That is possible. Okay, so quick 2-minute digression on physiology. Things coming far away, okay, we have some sort of lens here from far away, from infinity. Things are parallel. We all know that. If the eye doesn't make a correction, if the eye is not there at all, the parallel lines will remain parallel. That is, the image will form at infinity. But the retinal plane is somewhere over here. Plane 9, the retina is somewhere over here. So image at the infinity, you have to get to the retina. Okay. So from infinity, image at infinity, you are moving it towards the retina. If the system fails, you will end up somewhere here. Something that is very close on the other hand. It's going to look like this. Again, you have the retina, something that's standing very close to you. It's, it's all line things converging to a point here. If the eye is not there, the lens is not there, things are all end up over here. To get it to the retina, you have to move it in this direction. You have to do work in this direction. So when your myopic thing fails, okay, obviously the system that takes this image to this point here fails. So this is in front of retina. At least I have, some quick simple ray tracing we eliminated too. And then of course, if you remember, what we need is divergence here. You can say we need a concave lens. Okay, choose the correct sequence for the direction of blood flow. This was there in the one of the first question papers I set before GATE 2020 paper. So I just set a mock paper that had this question. And I suppose all of you know this anatomy fairly straightforward. Typically, they ask this in medical tests. So it was very predictable. So third year, they asked it finally. Systemic arteries, veins, vena cava, pulmonary vein. So vena cava, right ventricle, pulmonary artery, pulmonary vein, left ventricle. Aorta, systemic arteries. I think this makes sense. Vena cava to pulmonary vein. No. This is incorrect. And systemic arteries and then aorta, of course, that is incorrect. And then vena cava, systemic veins. No. Systemic arteries, they go to capillaries, then there are venules, then veins, and then vena cava. So that also is correct. In the healthy adult, which of the following regions brain contain primarily white matter? So the place actually, we looked at this. I put up a video on T1, T2 relaxations on MRI. There I specifically discussed this based on regions of this brain. White matter is actually gray now, gray matter is white now, and all that because of T1 contrast image, T2 contrast image. So this is some detail we have come across in, quite often, at least in terms of MRI. And this is corpus callosum thing at the center, white matter. Even otherwise, basic physiology, white matter is at the center. If you know that, you can guess cerebral cortex, okay, outside, basal ganglia, okay, limbic system model, okay, corpus callosum at the center connects things. You should be able to guess this. Skeletal muscles are recruited to lift loads. Force generated in the muscle due to contraction is not sufficient to lift the load. It is known as DAS contraction. Again, I had a poll about this on YouTube because there is some ambiguity here. Key says isometric, or any other answers possible. Notice if they did not give the statement, force generated in the muscle due to contraction is not sufficient. Actually, even if they give that statement, so quickest thing is, okay, you are trying to lift this, lift something, you don't apply enough load on it, you are not going to lift it. So let's pretend this is some heaviest metal on the thing that I'm somehow holding and trying to lift it. Okay, if we don't apply enough force, I'm not going to lift it. So there is not going to be any change in length. In that sense, isometric makes sense. But iso-inertial, iso-kinetic, there is something called eccentric contraction, where this is a case where you take a dumbbell and you release it. Obviously, you are putting lesser force than the weight of the dumbbell than what is required, so that your hand is going down. Okay. In fact, you are holding a dumbbell like this. There is no change, and you are giving sufficient load. Okay. So load doesn't mean, could actually, the tension remains same, could mean isotonic. In this case, load doesn't move, your arm doesn't move.
So distances don't change. It also mean isometric. Okay. But what makes the question slightly different is you're not holding it like this, but you're trying to lift it. So the statement actually, if not for this statement, isometric or isotonic are possible. Even otherwise, you're taking something, the stumbles, and releasing it. At the time, you have to give lesser force so that your hands are relaxing. The weight is going down. Okay, and you could do that so that velocities are constant, or you could do that so you could do it so that acceleration is constant. Okay, you could do it in an iso-inertial or isokinetic way. Acceleration or the load is constant, so somewhat following your hand. So technically speaking, force generated due to the muscle contraction is not sufficient to lift the load. It can be isokinetic, iso-inertial, isometric, or isotonic. All four are possible. Okay. Because they are very, very specific about the scenario. We have something, we are trying to lift it, we are not able to lift it. Let's say load is in the ground, we are trying to raise it, but not able to raise it. Obviously, we are providing lesser force. Okay. And load is not moving, our hand is not moving. Isometric makes best sense. But if you ask me, there is some ambiguity in the question. Isotonic, isokinetic, isoinertial are all possible. In all those cases, force generated can be less, need not be sufficient to lift the load. Yeah. So, yeah. So there are ambiguities. Some of you thought isotonic for good reasons. Unfortunately, can we really challenge this? I don't know. I'll leave it up to you. Okay. So the actual, only if this statement is given, this is known as eccentric contraction. That is the best term. If that is there, it's unanimous. These four options, I can think of scenarios where all four are possible here. So that's my verdict. Rest I will leave it to you, whether you want to challenge and how you want to make it concise scripts, so that the committee realizes, yeah, the question is ambiguous. Yeah, we made a mistake. We should actually give marks to all. Unlikely scenario. If any of you manage to do that, very well. Okay. Backscattered electron detector for a scanning electron microscope is used to topography, roughness. So actually, backscattered electrons, function of atomic number based on the size of the atom, the amount of electrons get backscattered electrons, function of atomic number. But that doesn't mean we can measure atomic number. We can say if say there is a grains of two different atoms nearby, we can actually say, oh no, this is one composition, this is one composition. Or we have alloys with varying compositions. We can get a contrast at best. Okay, we can get a change in variation due to variations in amount of intensity of backscattered electrons, and the change in intensity can be at best can give us a contrast. But no one really uses this to measure atomic number. Okay. So measuring atomic number, you'll have some other tests certainly up our this thing. We don't necessarily have to go for a backscattered electron detector. Okay. So we can get a contrast. I suppose the key is also D24, if I'm correct. I didn't check this one. So I think the key is D. Okay, just object in a couple of seconds if it's otherwise. Yeah, the SEM figure. So this is some detail that we have discussed in class a lot. So one of the questions in the chat, why not option A? There is a saying in Tamil. It's not a Tamil friendly audience. So I know Vallavanukku pullum aayudam. So they can measure anything and everything, give them something, give it to an expert. They will measure weight of the earth with a pin. Okay. So is a pin, can use a pin to measure the weight of the earth? You may think no, but give it to an expert, they will still manage to do it. So in that sense, study surface topography, obviously the amount of backscattering will depend, there will be some effect on the topography. So can be used to study topography, but is it used to study topography? Probably go for an AFM. Can be used and is used, there is a difference. Probably that's why I would rule out A. Okay. So that answers Kishore's doubt, I suppose. Right. So yeah, again, backscattered electron detector can be used to measure atomic number, but do they use it? Probably no. They will use something else. Atomic number, not chemical composition. Some X-ray, something, just use it, man. So you will get atomic number. Why have a electron microscopy? Just have some X-ray source, some reasonably nice light source. You should be able to measure atomic number. Okay, in the process of obtaining, yeah. So before I go that, is used to, let me just highlight, not can be used to. There is a slight difference in what they mean. Yeah, but actually a nice question. In the process of obtaining a magnetic resonance imaging, and the terms T1 and T2 time constants of the material are crucial to decide on getting suitable weighted images. Choose the correct explanation relating to these two constants from the following options. T1 is spin lattice, longitudinal relaxation. T2 is spin transverse relaxation. We are done. If it's an MCQ, I suppose it's an MSQ. I mean MCQ, not an MSQ, right? So yeah, this is what it T1 is longitudinal, T2 is transverse. We are done with it. Obviously another case. Then they have tried something. And notice the moment they give opposites, one of them has to be correct. Or okay, not necessarily, but at least if there are only two relaxation, longitudinal and transverse. If you know that information, either A or B, D has to be correct. Right? This is logic 1. This is logic 0. Better be this or that. One of the two has to be correct. Given X is real, all the even functions among the following. Yeah, we know this, like given functions, odd functions, sine power 43x and all, we know how to do. So these are relatively easy functions. Notice x is odd, mod x is even, mod x is symmetric, x is not symmetric. Okay, and then cos x is symmetric. If x is odd, 1 over x function of that, inversion of that is again odd. That's another property. So 1 over x is also odd. And few more details let me write. X square is even, mod x is even. That we already have that. So this is an odd into even function. This should be odd. This is again product division doesn't matter. So this is even into odd, or even by odd into, or divide or multiplication doesn't really matter. Holds good. So this is also odd. Now this is composition of functions. This is a function of composite function. This is an f of g with g is even. So x plus x minus x, there is no difference. So in the sense it's even. Okay. Yeah, you can substitute and see, or composition of an even function. F can be anything as far as g is even. F composited on g should be even. Or plus, there is no difference between plus x and minus x here as well as here. So that makes this even, this even. Yeah, if you want to substitute, use the definitions of even odd, you could do that. Yeah, you could actually use the definition. Substitute minus xc, you get negative or the same number. Coronary stent should be, actually this is a nice question. You don't want any clotting in the stent. It has to be thromboresistant. It's a stent. It's going to pulsate every heartbeat. Hopefully every heartbeat, and your heart is beating in rhythm. So it has to be fatigue resistant. It shouldn't break down after some number of beats. In a day, it shouldn't break down. Quickly calculate the number of beats in a day. Thousands of beats, it shouldn't fail due to repeated cycling. This is also correct. What happens is SMCs, there's something called in-stent restenosis. You put a stent, there is a blockage, you put a stent and open it up. Okay. Now the stent is not nice. This blood vessel wall starts growing on top of the stent. It grows and at the end of the day starts occluding it. That happens if there is accumulation of smooth muscle cells. There is also deposition of extracellular matrix. So when this happens, the vessel wall grows on top of the stent very, very crudely, again, which you don't want. So it shouldn't be promoting that. It shouldn't be supporting that. You should be avoiding these two. These two are failures, actually. So ideal coronation should do A and C. So I think, yeah, the key makes sense there. So very, very recognizable biomedical instrument question, just that it's an MSQ. So you have to be very, very sharp, else you lose marks. When a person is exposed to an electrical hazard, so first of all, they are asking for true statements. Let go current is defined as a maximum current at which subject can withdraw voluntarily. Yes, correct. Plus, so on, so under. Yeah, let go current by definition is that. Microshock, holding hand to hand is macroshock. Directly send the current to your heart, that is microshock. That is also correct. And then patient in an intensive ICU exposed to danger of microshock because you have using internal conductive electrodes in the vicinity of the heart. Yeah, you do catheterization, you are measuring pulse, you are measuring, you are also pulsing the heart to keep it stable. You are injecting some thermodilution to measure the heart pump. So there are so many things going on. You are putting in so many things. There is a lot of danger for microshock. Sending a small accidental current through the wires that you are putting, through the catheters. This is correct. 50 Hertz safe current limit for a microshock is greater than 50 milliamps. So had it been a microshock, even then this is greater than, man. Safe limit should be less than. So that itself says, and this is actually way, way high for a microshock. This is macroshock is close to that. Macroshock should be less than, close to 70 milliamps or something like that. Obviously, this is incorrect. Okay, sir, is it a physiologic response? So I have one question in the chat. So are we talking about 28 or are we talking about 27? 28. When a person is exposed to an electrical hazard, let go current is defined as a maximum current at which the subject can withdraw voluntarily. Okay, so now we have a general aptitude question here. So, there's a committee have teams of members, hopefully experts from bioinstrumentation, from medical imaging, from general aptitude, from mathematics, electronics, signals and systems and all that. So person who is setting this bioinstrumentation paper may not know about the kinds of questions that shows up in general aptitude. So, but the student who is writing it is very concerned about interpreting English here. Is microshock a physiological response? Microshock results from electrical current passing through the heart. That is correct. Is microshock a physiological response? So any objections to that? It does, I mean, at least did I read your question correctly, that precision in language, is some issue arising with precision in language? Yeah, let's, just think about it for a few seconds. There are physiological responses to microshock, but is microshock itself is a physiological response? Yeah, there are physiological responses to a microshock. This is yeah, but is microshock a physiological response? So one has to look at how this is clearly defined. And then, the problem is engineers will use it in one way, doctors will use it in one way, and it's going to be an issue. But I do see the issue. It's microshock itself is a physiological response? No. Microshock is a external event. Yeah, it's an event, and then there are physiological responses to it. Okay. Content, grammar. Yeah, take a definition of microshock from a very nice source, a reliable source, very standard book, and point out there are physiological responses to microshock, but microshock itself is not a physiological response. So there is, this option is framed, there is some ambiguity in the framing, so that should be addressed. Be very polite and find a nice definition. Okay. Content grammar, yeah, if you found a nice definition for microshock in a standard book, go for it. So which of the following statements related to the operating principle of pulse oximetry or correct? Pulse oximeter non-inversely, again, this is something that we have done in class, or if not in class, during COVID, many of us are like, why if you put a pencil, the oximeter is showing 98% saturation? We are all wondering about it. So we had time to read about this. So light transmitted through this. So what are the options here during systolic phase? Actually, I had an issue with the key. The key reads, I suppose, A. Key is A, B, C, I suppose. This is obviously, this is the 660 to 905, 850 to 950. So this is incorrect. Fine. This is not correct. This is correct. And this is correct. Yeah, this is isobestic. Sounds like a new term, but of course, just look at it. At wavelength at which HB and HbO2 same optical observance. ISO is same, so optical observance somewhat some Latin root makes it bestic. You could perhaps guess it. Okay, so this is correct. Question is, does it analyze light transmitted through the skin during the systolic phase of the blood through the? No, it there is a DC component due to diastolic phase. It gets light transmission not just during systolic phase. It should get a pulse wave like this, and after that there will be a DC due to all of that. So it's just, so I am getting picky here. Systolic is a problematic term there. See, the signal actually will look something like that. That will have a DC component, that will have an oscillating component. Perhaps you'll be focusing on the systolic phase, but the signal you are getting is this. Let me take a second look. So, if there is, no reasonable objection. Let's just take it for granted. But I'll take a second to call this. If there is an issue, I'll let one of you know. And if you're also worried about wasting money in challenge, I could also sponsor a challenge that I believe in. I don't mind doing that. So I can get back to this. Which of the following statements related to biomedical measurements are true? So peripheral nervous system, ENG is correct. Electrical activity of the retina and response light stimulus. This is something again very, very basic, but this is a trap. This is ERG that they are referring to. So this is not correct. Okay, this is ERG. The movements, put electrodes here, try to track eye movements, that is EOG, oculogram. Gamma, I suppose, has the highest frequency. P is actually atrial depolarization. We all know that, so this is incorrect. A and D. So again, the key there, I suppose, is correct. Okay, so the following mechanical prosthetic balls were invented as a replacement for diseased heart faults. Again, if you know some background knowledge on this, you can use a ball to stop the flow of blood at the right time, ball and cage ball, or a leaflet shaped thing to stop it. But globe ball is there, swing check balls are there in your cars, engines, and all that. Cars and bikes, not a hot ball. So again, I suppose B and C is the key. So no issues there. Okay, so we are starting to come across more interesting questions that you might be wondering, how do I solve that? Or the question doesn't make any sense at all. So those sorts of questions are lined up. So things will be somewhat interesting from now on, certainly for some time. Especially, if you have been wondering like how to approach a question, this is a nice part. Okay, due to COVID pandemic conditions, assume that positive or negative status of any individual are equally likely. There are 3 members in a family. If one of the members are tested COVID positive, conditional probability that at least 2 members. So when I take this is something, a lot of students make mistakes here. Very, very basic idea and probability. So that's fine. So, okay, there is a grammatical issue with one of these options. Electrical activity of neurons in the peripheral system can be measured by electroneurograph. No, it says can be. Yeah, you can measure it. There is no issue there. This says can be measured. Right. So this is there are no. This is a safe way of framing it. Yeah, it can be measured. So why bother about CNS, PNS? So let's come to this interesting question. Due to COVID, this is a standard thing that students fall for. I suppose answer is 4/7. That is 0.571. So when I take classes, when I introduce probability, I say, okay, now family has 2 children. One of them is a boy. What is the probability that other person is a boy? No, you can't do 1/2 into 1/2. There is an issue. You have to enumerate. Then okay, the older person is a boy. What is the probability that the other person is also a boy? Then suddenly just because the old person is a boy, how does that change the probability? All those questions we have discussed. Same question essentially shows up here. So your total sample space, positive, 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 negative, positive, negative, positive. People are different, not like photons. Okay, so you can identify them as which person is testing positive, negative like this. Then we have negative, positive, positive. And then we have this negative, negative, positive, negative, positive, negative, and then you have positive, negative, negative, and then we have a negative, negative, negative. These are the 8 possible cases with 3 people. Enumerated them. Information given is one of the members has tested positive, which rules out this case. All these cases, at least one of them is positive. So there are only 7 possible cases given this information, and at least 2. So this is fine, this case is fine, this case is fine, this case is fine, this case is fine. Here only 1. So 4 possible cases there. That's it. So simple enumeration. I stress this, very, very basic idea in probability, boy, boy, girl, boy kind of problem. They know they made it, following the trend. COVID pandemic, 1 person is hitting. Okay, so series RLC not an issue. I think I leave a quick pointer. Leading power factor to lagging power factor. Just play with the impedances. Z is R minus J into 1 by omega C plus J omega L. Okay. If you calculate this, you should, and let me also write what is omega. Omega is 50 hertz. So 50 into 2 pi, approximately 314. Okay. If you calculate this, you should get 10, okay, minus 16.14 J. This is leading power factor. Okay, there are more capacitive terms, so that makes it minus J. You have to make this Z nu plus J omega L nu. This should become 10 plus 16.4 J. So what was leading becomes lagging. So as far as things are conjugates, the power remains the same. So, what change should you make here? That's what they are asking. And yeah, you're changing, only making a change here. You should, of course, increase that. Quick algebra, 1 or 2 steps, you should get the answer. I get that to be L. Okay, we want L to be 152.825. No issues with that. Okay, so 1 or 2 steps down the line, you almost have it. So from this, you have to convert, you have to change this to this by changing this inductance. That's a question. You could do this very easily. LS 152.825. No issue there. And this is in millihenry. So thickness of a piezoelectric crystal. So last time they gave it as a 2-mark question, mixing and matching with something else. This time, okay, I hope it's a 1 mark. For resonance, the thickness should be half the wavelength. Condition for resonance. That makes it C by 2F. I think if we calculate it, you can quickly get this to be C is given. Don't use speed of sound in blood or tissue, 1500. It is given in PZT to be a lot higher, solid. Use that C, and then your frequency is given 5 megahertz. If you use that, you should get 0.435 into 10 power minus 3 meter. That is mm. Again, not an issue. Very, very simple question. Okay, power consumed by a 3 ohm resistor is 12 watts in the given circuit. Value of the resistor R in the circuit is actually, straightforward question, slightly lengthy, but you could kind of solve it. Any of you managed to solve this in the exam? There are, again, electrical circuit. You could solve this many ways. The way I would do this is I first look at information about this is given. And so I know this power, so I know this current, so I know this voltage, I know the total voltage, so I also know this voltage, I know these two resistors, so I can calculate these two currents because I know the voltage across them. And if you know these two currents, I know the current going through these three. And if I know this current, I know how to split it between that. So that's my line of thought. So first thing to do is to find this voltage. Towards that, your I square R is 12. Okay, I square is 4 for this 3 omega. Let me have 3 omega is 2. Okay, we have 2 flowing there, 2 amps. That makes V across 3 omega, essentially this V, 2 times 3, 6 volts. So there is a 6 volt drop here. There is a total of 10 volt rise. So this should be 4 volts. This is 4 volts. The current here, the current here. This is V by R. So this is 2 amps. And this is 4 amps. So the total current here is 6 amps. So now this is a matter of splitting current division. Whatever you do, the total current entering, 2 amps is entering. So what should be this R? You could quickly do that. Notice 2 amps takes 6 amp. Let's read this. This is RT. These two and R in parallel. It's proportional to RT into 3 plus RT. It gets divided between RT and 3. One equation, you can find RT. What is RT? RT is 2 into R by 2 plus R, 2 and R in parallel. So you can find, find RT, and then find R. Okay. So step 1, step 2, and then step 3. You should get it. So for practice, I gave like 50 questions. Out of that, almost one came the GATE exam. Actually, not one. There are Cayley Hamilton and all that. If you add that, there are many other questions. But realize almost minor tweaks in numbers I had given this for practice, right? I think it's a PYQ. So yeah, there is only one trap here. This should be 2 pi I into residue, sum of residues. There is only one pole. So residue of, let's say, residue at ZM. And ZM, just be slightly careful. For the sake of everyone, let's do this. 3 into Z minus I by 3. Okay, the pole is I by 3. There is one pole. It's an entire complex domain. Nothing mentioned about any specific region. So whole domain, but there is only one pole. So this should be 2 pi I into residue of this. Remove the singularity, evaluate the rest of the function. Okay. So Z cube minus 9 by 3. I removed the singularity, evaluate it at the pole at I by 3. Okay. Yeah. So this is 2 pi by 3 into Z cube is I cube. There is one more I power 4. That is 1. I took that 3 outside. Oh no, this I by 3. So this is 1 by 27 minus 9. There should be a J somewhere here. Yeah, J is outside. Okay. So this is, I multiplied it. It became a 1. So it's this. Okay. So this is 2 pi by 81 minus 6 pi I. This again straightforward, not an issue. So in a paper like this, where there are so many traps, if you're making a mistake in a question like this, that is what going to make a difference at the end of the day. So we know our silver bullet for differential equations. They kind of make it slightly harder with we could kind of recognize it's a first order form, put a integrating factor, do that. But even otherwise, we know how to substitute things and verify. So suppose it is A, right? Not an issue. Just verify. Wondering about integrating factor, dy by dx plus p polynomial of x is polynomial q of again of x. Solution for this is y e power integral p dx is integral q e power integral p dx plus c. Okay, and what is p? P is -1. So integral p dx is minus x plus c, and I'll forget there is one more constant there. And then e power integral p dx is e power minus x. So y e power minus x is cos x e power minus x dx plus c. There comes the slight trouble in this here. Now we have to do this, uv minus vdu, this integrating by parts. Should we take cos into the bracket, exponential into the bracket? Again, if you know the I late and all that, usually do that. Take cos inside the bracket, becomes sin x. You do one more time, you get this integral again. So you can actually find this integral. Okay, let's call this term as I. I is e power minus x d sin x. That is sin x e power minus x. Okay, minus sin x derivative of e power minus x. So this becomes a plus. Appears like we got back almost where we started, but that's a point. You do it once more time. Sin x e power minus x plus integral e power minus x d of minus cos x. Okay, and there you have it. Sin x e power minus x. This is minus cos x e power minus x. Okay, minus suppose this is correct, right? If you take derivative of this is sine. This is uv minus of again the product of these two. Yeah, so this is cos x with a minus. This becomes a plus, but you also have derivative of e power minus x, so this remains minus. There you see it, you got back I again. So 2i is this, I is this by 2. So just in case you wanted to do that. Anyways, let's get back here. Okay, yeah. Anyone managed to solve this question right now? Not during the exam, right now. Hard because it involves an inverse problem. From the Bode plot, you have to guess the form of the transfer function and then do calculations. So finding transfer function from Bode plot, if you can't do that inverse problem, we are going to have trouble. Anyone managed to solve this? Okay, so there was this auto horn sound. Probably the student is busy traveling outside or something like that. Understandable. So let's get back to our this problem at hand. Yeah. So did anyone guess the form of h of j omega? So when will the magnitude remain a 1 but only the phase change? So magnitude doesn't change at all. Okay, so one student is thanking me for substitution method. Yeah, that's a basic trick. Everyone says that, but glad it helped you. So let's get here. So when will the magnitude remain the same? And notice the first order system phase is going to change by 90. There is one term, not a first order system. There is one pole or zero. There are like two things, perhaps things can change by 180. If things are conjugates, numerator and denominator, then magnitude is going to remain 1. That motivates me to try this form. And also I get a 90-degree phase change from each of the terms. Each term gives me 90 degree minus 90 degrees. So combined together, they give me 180 degrees change. So this is the inverse problem that I mentioned. If you could do this, if you have done this, rest of the problem is straightforward. Okay. So A is an unknown. Oh, no. Yeah, that you could find from some information. So the magnitude of this is always 1. A square, root of a square plus omega square here. And again, denominator root of a square plus omega square. So magnitude is always 1. What is the angle? H is notice tan inverse of the numerator angle, that is minus omega by A minus tan inverse of denominator angle, tan inverse, let me avoid some clutter there, minus tan inverse omega by A. We know tan inverse minus theta is minus tan inverse theta. So that becomes minus 2 tan inverse omega by A. Okay, how does this help us? Because we are given omega, this angle at a very, very convenient point, 90 degrees. So minus 90 degrees, I'm presuming this in degrees is minus, okay, actually, let me not repeat it. So this is minus 90 degrees. So tan inverse of omega by A is 45 degrees. So omega by A is tan 45, that is 1. And specifically your omega, notice at this point is 10 power 4 by A is 1. Tan 45, that is 1. So A is 10 power 4. You can have that there. Once you know the transfer function, you could do simple. Yeah, problem is not over yet. Your y of s is 1 over s a minus as by s a plus s. Okay, you have to do partial fractions. If you do partial fractions, of course, it's going to be 1 over s term here, and then a plus s term here. The coefficients, I suppose you could find out. This is 1 and this is a 2. We also already found out a. Okay, so we know y of s. This is simple. We know how to do y of t. This is u of t or 1. Okay, 1 minus 2 into e power minus at. So find y of tt as 0. Just find it. Suppose you could do that. So if you just solve time, you should get that in seconds. Notice answer is in microseconds. So dot, solve this equation, find t. You know a, only unknown is t. You can find that. Your time should be 10 power minus 4 ln 2 seconds. That is 10 power minus, that is 100 ln 2 microseconds. Okay, does make sense. So the hardest step here is, of course, yeah, we know we have details in this figure. If you know the form, we can find the parameter, but the question is, if you had written this form, answer is straightforward. Block diagram of a 2-tap. So last time they troubled with infinite tap FIR filter. This time they troubled with 2-tap high pass filter. Did anyone solve this or figured it out by now? just to have some contrast and flavor in the discussion. So let's see, let's write down what we know. At least this figure we know how to read. H of z is beta 1 plus beta naught z inverse. Now, what is the maximum value of this, minimum value of this? The maximum value is 1, ratio is then how do you find the coefficients? So we have to do complex number minimization. I can give you one hint. We are always looking at, just like frequency response, in continuous systems, we look at j omega axis. Discrete systems, we look at unit circle. Frequency response, essentially all the variations we studied in the unit circle. So this is where we study, we vary z. So mod z is 1. So we are trying to maximize and minimize this function. Parameters are beta 1, beta naught. Okay. We are trying to find the parameters that maximizes this function. H of c. Actually, notice on this form, you could say something. I think 0 is at minus beta naught by beta 1. There is, if you know actually pole zero plot, how to use it for a discrete time system. Okay. The point that is closest, the z naught closest to the 0. Okay. That should have the smallest gain. And the closest point is, of course, this. The point farthest away from this 0 in the unit circle, that should give the largest gain. Okay, and that point is, of course, over here. Every other point is not, this is the farthest point. So you could use that info and, try to find the maximum minima, but there is a slightly simpler way here. So we are trying to find maximize and minimize this. Triangle inequality. The moment you are not dealing with scalars, first line of attack is anything with vectors, complex numbers, anything with vectors. First line of attack is triangle inequality. It says, notice, so this is a complex number. Okay, it's not easy to split the real and imaginary parts. So we have to deal it as such as a complex number. Z1 plus Z2. This is less than Z1 plus Z2. So modulus of this is less than sum of the individual moduluses. So why do I say that here? So H of Z should be less than or equal to beta 1 plus beta naught into modulus of Z inverse, which we know is 1. We are looking at the unit circle. So we got some information. Can we quickly verify? So this value in fact is 1. This modulus is 1. This modulus is 1. This modulus is 1. This modulus is 1. So all this beautiful triangle inequality, we wrote down some nice thing, but at the end of the day, all 4 options are cooked up. You can't eliminate even a single option at this point. So we have to use a triangle equality, that's it, but a corollary of that. Can anyone fill the picture right now? Specifically, if you are thinking of joining the program, the next batch, you answer a question like this, I'm certainly impressed and you are in. For lack of time, the corollary is this: beta 1 minus beta naught. So the minimum value is this. This is the minimum value. The maximum value is this. Notice this transfer function is always less than this value. I mean, always greater than that. So that's the minimum. It's always less than this value. So this is the maximum. Okay. Now, can we eliminate? Yes. We know beta 1. The ratio of the 2 is 2. This by beta 1 minus beta naught is 2. Does this satisfy? Yes. Does this satisfy? No. No. No, notice these two are cooked up so that you get a difference of 0.5 to give a, you have a 1 by 0.5 here so that you get a 2. Actually, a simple question, if you either this is actually method 2. If you know pole zero plot, you could tackle it. If you know triangle inequality, some inequality in math, you could also tackle that. Okay, block diagram ideal system. Was anyone able to verify this question? Again, the key there, I suppose, is correct. Okay, I did not find any issues with that. Question this question quickly. So we have 1 more hour. Okay, great. Yeah, the only the thing is, it might be tempting to take the Laplace transform route. Oh, I know how to take Laplace transform with exponentials. I know how to take Laplace transform with products and all that. That might be the only thing that might slightly obfuscate it. But if you avoid that Laplace transform route, things are in time domain. You are trying to find something at 40 to be same. You are staying. You are trying to find an equality in time domain. Stay in time domain. That should give. Notice, let's call this yi. Let's call this yr. Your yi is e power minus rt ut convoluted with whatever input it is. Let's say it's actually unit impulse. So convolution is a function, is that? So Arnindu, can you just quickly help me here? So the Dirac is will just give you this function, right?
Yes, sir.
Okay, thanks. Because my recall points are slightly off now. Okay, so notice this is convoluted with the Dirac, so you just have that function. Y real, this is beta into u of t minus phi t. Okay. Again, it's convoluted with Dirac, so it's the same function, but it's summed with it's added with this term e power minus alpha t minus t and then u of t minus t. If you had got this question in the exam correct, this is a type of question that can actually give you a point or two advantage, and that makes the difference between topper and yeah, you scored well, but questions like this will determine even silly mistakes. Even toppers do that. They fall for traps. The committee falls for traps. I fall for trap. So everyone falls for traps. Okay, but a question like this that looks obfuscated, you get it correct. You have a major lead. So why is this specifically? There is not actually. These are times. Not in the Laplace domain. Okay, so this evaluated at time 40, e power minus alpha 40, u is 1 at 40, u of 40 is 1. It's either 0 or 1, it's 1. U of 40 is 1, so I have a beta there. U of 40 minus phi t, u of minus t is 0. That's it, I just have a beta, or I still retain that beta. E power minus 3t. Notice 40 minus t, that is u of 3t, that is still 1, that is positive. Okay, this term remains. So e power minus 3t. I think there you have it. Just rewrite it. You should get the answer. Okay, you have beta. Pull out the common term e power minus 3 alpha t. So it's either this or this. And very specifically, if you pull out minus 3, you should get this. Yeah. Okay, one more interesting question. So we had this special session where we looked at trying to solve differential equations using op-amp circuits and all that, but we couldn't solve that, right? We had some other issues, but a few points became very obvious. Something that looks very complicated, there are very few things going on. Even if you want to change the sign, you have to put an inverter over there. Notice 4K is an inverter. Okay, 2K is an inverter. So if you have VI here, you have minus VI here. If you have V0 here, you have minus V0 here. So at least that point, I suppose, was evident in the extra classes that we spent, at least some of you. And these are the things that in the long run, all this drops kind of add up and make all the difference. So anyone managed to solve this? If you solve this, actually very nice. It's obfuscated, but it's not all that hard. There is a summer here. There is a summer here. So there is a sign changer there. There is a sign changer there. What is this term? There is a picofarad, 1K and all that. That is a integrator. That's it. And you are looking at things in Laplace domain. So integrator is 1 by SRC. Okay. Yeah, differentiation is S f of s, integration is 1 by S f of s, right? That so integrator is just 1 by S into whatever transfer function is. That is RC, of course. So output you get here, V naught, is you get a sum of two terms, this term and this term. This term is just minus VI. So that is, take minus VI, it has a gain of 10 by R2. Minus 10 by R2 to be slightly inverting terminal. And then there is a summer here. So whatever comes here gets summed up. Okay. Again, it's an inverter. So there is, notice this is a sum of two things, Vi and minus V naught. So Vi minus V naught. It gets summed at this point and gets integrated due to this. Yes, RC. Okay, this is R and this is C. That values will actually turn out to be not all that important for this problem. That's it. So from this relation, try to get V naught by Vi, and then this is an all pass transfer function. Okay, that means it doesn't have a polar zero, or the pole and zero occurs at the same point. Okay. Let me just complete the picture here. So if you rewrite this, what you should get is V naught into 1 plus 10 by 5 SRC is 10 by R2 plus 10 by 5 SRC. There is a factor of 5 somewhere over here. Quickly, yeah. This component has a gain of 10 by 5. So this is technically 10 by 5. Okay. So this is the integral term that comes here that has a gain of 10 by 5. So if you rewrite this, you get this. Notice for the zeros and poles to be the same location, so that it's a hall pass. There is no going up or down in the Bode plot. 10 by R2 should be 1. So we had lots of issues with this question. G of t is given. We know initial value theorem, final value theorem in and out. And we do it, we got infinity, and the key says it's minus 11. So where are things going wrong? Anyone figure out? Actually, this is a candidate for a possible contention. Notice, so this also we know. So yeah, F goes to F, G goes to SF. Okay, SF minus, if you want to be slightly careful of 0 minus and all that. So calculate again, use one more initial theorem to calculate this term, right? And then so G of t, G of 0 is S into G of S. So that kind of become S square into 1 plus S by S square plus 12S plus 32 minus this term if you want it, calculate that term. If it is a non-zero, retain it. But at this stage, try to apply initial value theorem, h tending to infinity. This is infinity, but not the way to do it. Notice n of s by d of s, initial value theorem, final value theorem, all of that applies. if order of n of s is less than order of d of s. The moment you have this higher power order here, s cube and s square here, you can't apply IVT, FVT. So yeah, this was a trap. Actually, we may not have known IVT, FVT in and out. So the way to do that is same old, do partial fractions, take Laplace transform, take inverse Laplace transform, take derivative of the function. And let me make a note of this here, minute or two, because this problem might demand some contention. I did it once, I didn't really check that, but so this is s plus 8 into s plus 4. As a partial fraction, I have, a by s plus 8 plus b by s plus 4. You can find a and b, you know how to do that. I got 7 by 4 into 1 by s plus 8 minus 3 by 4 into 1 by s plus 4. Okay, so your f of t technically is 7 by 4 e power minus 8t minus 3 by 4 e power minus 4t. To be slightly picky here, you have a u of t. Okay, so your g of t is derivative of this that you could do minus 56 by 4 e power minus 8t, 8 times 7, and then you have this plus 4. I think the things cancel. This is 3 times e power minus 4t u of t. That's it. So just find g of 0, you should get minus 11 at this point. Substitute t is 0, you should get 0. And if you want to be slightly correct here, this also has a derivative. 7 by 4 e power minus 8t minus 3 by 4 e power minus 4t into del of t. So this becomes this function evaluated at 0. Actually, they gave the hexaxial reference system and all. I asked everyone to memorize this, the angles. Lead 1 is at 0 degrees. Lead 2 is at 60 degrees. Lead 3 is at minus 120 degrees and so on. So even if you're slightly confused, notice AVL is along this side, right? So this angle is 30 degrees. Okay, lead 2 is at 60 degrees. Whether you use the figure or you recall that, lead 2 is at 60 degrees, m is vertically downwards, it has no component along I, and the component along 2 should be phi cos 30. It's this. Yeah, practice makes a man perfect and all that. We study about it. We do mention this in class. You play violin and your nerves get more efficient for signal conduction. The way it happens is this. Actually, myelination gets better and better. Diseases like Alzheimer, myelination actually gets affected. So it's to improve this conduction thing. Essentially, there is resistance for conduction, it improves it. So when things are same, it's easier to compare. Myelinated does better. Myelinated things make more efficient, so it concerns lesser energy. Okay, again, when things are same diameter, same length, we can compare things. Unmyelinated conserves more energy. Myelinated is more efficient. What makes things here is irrespective of diameter length, so again, resistance is proportional to length and inversely proportional to diameter. Bigger the diameter, no resistance for signal conduction. So diameter does make sense. So safer bet is this. Compare same diameter length thing. Wow, so they gave so many hard questions on biomechanics questions. 6 students staying here. I hope. How many of you got this in the exam?
Okay, easy pickings. So, if you are making a mistake here, you could forget things. This is correct. Okay, tension is here, 20 degrees. Weight is somewhere here. Notice this is in newtons, 30 newtons. Component of that is T cos, T sine 20 degrees. Momentum is 15. That should be equal to 30 newtons into its momentum, that is 30. Both are in centimeters, so I'm not worrying about their units. So you can find tension to be 175.5, 175.4, whatever it is. ED by rho D. So I put this gate 2020, 2021, they asked us Moen's Corti work, and yeah, it's there in YouTube, publicly there in YouTube. I put it before 2020 exam. So person has a total blood volume of 5 liters, 4 liters this in pulmonic circulation. Only issue here is blood drop doesn't have one path starting from right ventricle to left ventricle. We know there is bifurcation at each. There are forking at each bifurcation of the artery. So it has a choice between this artery or this artery. Then it branches, and this thing is not symmetric. Okay, that makes the transit time across. So there are multiple paths for a blood drop to flow. That makes the transit time not a constant. One path, it's very takes a lot of time. One part of the, so one place the blood has to go to the leg somewhere deep close to the nail and get back to the heart. Other part, it nourishes a tissue close to the heart and just gets back. Very short cycle. So the time that it travels varies from path to path. So because of that, transit time varies. Question is not that well framed. What is transit time? Time it takes to go through a path. There are multiple paths. Each path has a different resistance, different length and all that. So transit time varies. But having said that, what can we make? Time taken on an average, at least this much time or something like that. Certainly if 1 liter of blood gets pumped from the pulmonic circulation, okay, all of that 1 liter got replaced. 5 liters take a minute. So 1 liter, the moment the 1 liter blood in the pulmonic system goes away, this drop will also reach. So 1 liter takes 1 by 5 into 60 seconds. 1 minute, that is 60 seconds. Okay, the simple answer is this, but if you understand the concern that I raised here, transit time varies. So no, nothing mentioned about the assumptions about it takes the same time through any path. None of that is mentioned. So technically there is some issue here. If you can raise a nice objection, go do that. Okay, objection. Based on stress strain curves of 3 different materials XY shown in the figure, which of the following choices is correct? Okay. Again, I took a poll in YouTube because I don't agree with the official key. And I think we had a discussion, some of us had a discussion on YouTube. There is this community session, we post things. So yeah, what's your take? Question worth challenging, certainly challenging. When I looked at this question, okay, this is metal, hydroxyapatite is almost bone, then some rubbery polyethylene. Metal, bone, polyethylene. That's what I thought. Key says, hey, what is key is B, I suppose. Key is B. Key says hydroxyapatite, the bone crystal,
titanium, polyethylene. And they make a serious mistake. This figure is directly from Princeton links. They make a big mistake there. See, modulus of titanium certainly higher. So again, to help you with some numbers, titanium how come? What is a modulus of hydroxyapatite? Which one is stiffer? So let me give this is titanium corresponds to 55 to 114 gigapascals. Okay. Hydroxyapatite corresponds to approximately 6 gigapascals. You can take that from a nice reference. Okay. So this is 6 and somewhere over here is 114. Yeah. So the reason to choose this is going by brittleness. I say that is not correct. This is correct. And the reason I'll also give you a fair. Of course, people who chose B are not going to contend. I'm hoping one of you chose A. This is based on modulus. Usually, if you actually go take a book figure, they will be very careful about one detail. They'll put a X here, they'll put a X here, and they will put a X here. And properly they will mention X denotes failure point. Okay. Go take a book like Osgay or Norton, book back. Of course, this kind of problem we have discussed, right? There in book back, Osgay or Norton. So they will mark an X, they'll clearly say there is this failure happening there. So when they draw this curve like this, does the curve end there? The person did the experiment till that point? It's not clearly stated. I still don't know if that is brittle. If they put a X there or put some point there saying failure point, we have something for argument. Okay. What I am saying is this is going on and on. So stiff. Okay. Failing again, metal is somewhat ductile, going somewhere else. It's failing here. Now I'm comparing slopes. So this is titanium, hydroxyapatite, polyethylene. Okay, that's they have made a mistake here, according to me. So that means all of you could gain marks. So yeah, those who chose B might be temporarily feeling happy, right? Okay, key they made a mistake, but I mean committee is in your side, but they made a big mistake here, and it should be MTA. Okay, should be MTA. Okay, so we have 30 more minutes, so let's start saving some time. This is P and L example problem. Okay, they deal with variables, they give some numbers. That's the only difference. P and L example problem. Okay, this is correct, verified it. Biological study experimental values are measured from 6 subjects given in the table below using this linear regression coefficient for estimating the weight of the heart based on systolic pressure. Systolic pressure in mmHg, heart in this thing. Notice I gave this one problem. What is half value layer? Then one student pointed out you didn't give the units. If it is in centimeter inverse, it is this. If it is, what if I write the answer in meters? What if I write it in millimeters? It's a coefficient. It does have a unit. Okay. They did not give units. Rounded off to 2 decimal places. In what units? That's certainly a big problem here. Okay, but other problem is you do regression. There are 2 coefficients. This is a constant. This is also a constant. They seem to refer beta 1 as a linear regression coefficient. But so what do you call beta naught as?
So there are two coefficients which they are not very precise, they are not very clear. That is fine. Okay, they can say no, only 3 legs for the rabbit that I caught. Like that kind of argument you can make, but at least in what units? Okay, at this level, because they penalize for units, committee should be penalized for not giving units. Okay, so they should make it MTA for one detail. A question to call your time and went wrong. Yeah. Get marks for all, man. We all know how to do it. In 10th standard, 12th standard, we have this thing, regression. So you can squint at it, we can do neural networks, deep learning neural networks. You can fit millions of parameters. 2 parameters, okay, at least you can get the slope approximately. But they have made a mistake, units. Okay, so my suggestion is contended, and it's a very valid thing. They didn't give the units. So this is fairly straightforward, just a trap. Yeah, we know divergence theorem, but this region is not a sphere. So anyone did, okay, divergence of F is 4. Divergence of F is 4. Now 4 times volume of a sphere of radius 3, of course you are done. Right? So divergence is essentially, notice this is linear, so divergence is a constant. So if you do this, convert this into a volume integral, you're essentially this constant times the volume. So constant times the volume of the cone, 4 times 1 by 3 pi r square h, and with some basic thing, this is 3, this is 3. X square plus y square is less than or equal to 9 square. Radius is 3. So r is 3, h is 3. You could quickly find it. I think the key is fine. No issue with that. Magnitude of the current gain. So, okay, this is a question on BJTs, right? Okay, fine. They did not, they give the circuit. So if you know how to do all the circuits, you're done. Notice IB is ion split. Take ion, split it between these two resistors, 5 by 6. Okay. And I load, you are splitting between 100 IB between these two resistors. So 10 by 10 plus 1. But yeah, this flows this way, direction is opposite, so you have a negative. Oh, they are asking for the magnitude. Okay, someone said, oh, there is a mistake here. Okay, so then so I load by I in, magnitude of that is what is this? Just product of all this, 5 by 6 into 10 by 11 into 100. So I think the key makes sense, right? $75.5. So this is a trap. Yeah, we did aptitude at the beginning of the paper. Usually, typically 52nd question they set a trap with English grammar. Hey, go get 2 marks in this problem. In what units? Okay. See, they are being unreasonable, right? So be reasonable. Okay, linear temperature coefficient of the material is this. Again, there is divided opinion. Key is 44.44, and then we have like 40. Everyone is getting 40. Should be content. So I'm going to say a detail that that was taken for granted, or is or not into 1 plus alpha delta t. Needs to be carefully interpreted. Or not is not any resistance, just like this thermistor, you have an exponential fit, give me one value, I'll find another value. That's not the way to interpret R naught. R naught is resistance at 0. And typically if alpha is in degree Celsius, this is in degree Celsius. Okay, or in other words, this is a slightly misleading expression. You are calculating changes in degree Celsius. That's all this delta T is. So whatever temperature it is, if it is 75 degrees Celsius, put it there. Delta T is 75. 25 degrees Celsius, put that. Okay. Or slightly better way to write this is, okay, so if you misinterpret it, you will get 40. So let me write it slightly better. This is alpha T. In fact, this is essentially, and so on. This is essentially take a polynomial, make a linear approximation, you get that, right? So this is alpha T. That makes it 50 is R naught 1 plus alpha at 25. 60 is R naught into 1 plus alpha into 75. Now we can get rid of R naught by dividing, we know that, then we can find alpha, then we can find X. That will be 44.44. So the key is correct. You have to interpret this linear temperature coefficient correctly. Or the T, if you write it as delta T, you should what delta T, you should be careful. It's not same as thermistor thing. There is no ambiguity here. RLC series, this thing, okay, you could do this. So let me not spend time here. Okay, this key is fine. I did get 2.63. Okay. Anyone solve this? I did not find time for this. Okay. So I skipped MOF 56 and 55. MOFSET and BGT. BGT, at least if they actually they ask you to find BZ things, you can play around with this, but they actually what they are looking for is small signal amplification. I am going to presume the key is correct, but I have one takeaway. These questions are showing again and again. What this is, given some signal, how do you amplify it? Okay, so transistor amplifiers, of course, specifically important for biomedical engineers, the design of that. How do you bias this amplifiers, and once you bias this, how do you ensure this thing properly works? Okay, so questions are very recurrent from this. There is one chapter in Sedra and Smith that discusses this. Okay, slightly hard read chapter. If you do that chapter, I think you at least have 2 marks in all gate papers. Okay, but in order to understand that one chapter, you have to understand 2-3 chapters before that. What is BJT terminology? What is MOFSET terminology? Then get here, understand a couple of equivalent circuit models, small signal model. It's hard, but 2-4 marks are there. And the reason they are asking us, biomedical engineers need to know signal amplification. That's why they are asking this again and again. This question as well as this question. Okay, yeah. So let's get back here. Ideal op amp, infinite gain, infinite bandwidth, this thing. How many of you put -10? Okay, so I think the key here is 4.6. That is correct, because I did put a video discussion of sir, there is positive feedback loop, so it should act as a comparator, and so it should desaturate to -10. Regarding that, I had put a solution discussion of iron paper 2021 paper. There I specifically mentioned this issue. Notice there are 2 feedback loop. Now the issue is what is dominant, what is is the negative feedback dominant. Things are in linear range and all that matters. And so in this case, assume linear, see if there is a contradiction, see if V0 goes to saturation. Okay, assume linear. If you assume linear, you can use all the rules of op amps. Solve for this. 0.1 minus, let's say this is V. Let's say virtual shorting holds good because it's in the linear range. Okay, in the linear range, even with this positive feedback, it holds good. So do 0 minus 1 minus b by 1k is b minus b naught by 2k. One equation. 1 minus b by 1k is b minus b naught by 5k. Another equation. Solve it. See what value of v naught you get. V naught you get to be 4.6. Well within saturation limits. So linear assumption holds good. Okay. So you are fine. Only if you get a odd value here, you get plus 10, minus 10, 20, minus 20. Anything above 10 or anything below minus 10, initial assumption is wrong. It is not working in linear range. It has saturated. Then it works like a comparator. Then it's, okay, this voltage is higher, then it's minus 10. That's a way to do it. Yeah, unfortunately, okay, this is almost the same question they gave it in 2021. There the trap was everyone solved for linear thing, and trap was thing was acting as a comparator. Here, most of you might have known that 2021 question. So it's a comparator, so it's minus 10. Probably that was a trap. Yeah, they are playing with you. Okay, independent voltage measurements. So anyone know how to do this? Okay, great. I think hopefully, in one of the mocks, one of the standard things they ask in instrumentation paper is sum of two Gaussian random variables. Okay, mean and standard deviation are given. X1 follows normal with mu1 sigma 1 square. I'm writing it in variance. X2 follows normal mu2 sigma 2 square. So question is, what does x1 plus x2 follow? Again is a normal distribution. Mean will be mu1 plus mu2, and then this will be variances add up. Variances are additive. Standard deviations are given. Find variances, add the variance. Okay, take square root of that, you should get the answer. So square root of 0.02 square. So your two variables, it also holds good. Okay, now, okay, two variables, if I add a third variable, it's one more normal with the variance getting added up. So that I'm going to presume you follow. So 0.2 square plus 0.2 square plus 0.15 square. I think that should give you the answer. Okay. Yeah, I think that should give you the answer. One of you could quickly calculate this, get something as 0.25. And notice 0.25, they are very, very strict on. I get 0.2508 or something like that. They give 0.25 to 0.26. Okay, there is no logic in giving a range. Okay, official answer key. All this happens, yeah. Moving coil voltmeter. These are all POIQs, man. Instrumentation POIQs, man. Voltmeter or ammeter, they ask it. Okay, this many deflections is, this many deflections is. It's in series, new resistance or shunt. 500. So you have 50 here, and you have one volt across it. Okay, so current is 1 by 50. Same current flows through this. There is a 500. There should be 499 across it. 499 should be I times RSH. I is 1 by 50. Okay, I think that is 29 something, 29500, 24950. That's it. That's correct. Hall effect flow meter. Anyone solve this question in the exam? The blood flow meter we studied about. E is BLV, that is BLQ over A. Okay, that is BLQ by
pi L square if L is diameter 4. That is what they are referring to here, as far as I know. That is Faraday's law of induction. There is a moving conductor. There is a charge developing across the conductor. That is different from flow of charged particles and that drifting due to an external magnetic field and creating a potential. That is Hall effect. And so the question is actually very simple. So flow is notice E by B, and then there is a pi here, there is a L here, and perhaps there is a 4 if you want it. So there is a Q actual, then there is a Q measured. So pi B remains as such. E becomes 40%. What you measure is 40% larger, 1.4 E. Okay, a diameter is 10% smaller, so 0.9 L. What they are asking is, this is given, Q measured is 100. What you want is Q actual. Just take ratio of these two, you should find it. So I think 100 by 1.4 into 0.9, that's the answer. Okay, yeah, 100 by 1.4 into 0.9, that gives us 79.37, I suppose. 79.37. Okay. So problems cannot get easier than this. Full bridge circuit, plus epsilon, minus epsilon, minus epsilon. B output, G epsilon source voltage. One tick they put, that is, they give Young's modulus and all. So G, this is sigma is E epsilon. So sigma by E Vs, and they ask you for V0 by Vs and G sigma by E, and they ask you m pi inverse, the same unit that they have given m pi. Just substitute the numbers, you should get it. I hope most of you got this. Okay, to be specific, 40 into, sorry, slightly they are asking for this. Sigma Vs 40 into 2 by 10. No unit conversions, nothing. Unfortunately, in this question, students made a mistake. Yeah, tidal volume is 500 ml. You understood that part. So many of you did 500 per breath. So that 18 breaths per minute, that is amount of volume of this perfusion. Ventilation is 500 into 18. That divided by 50 ml. Stroke volume is the blood heart pumps per minute into 120 beats per minute. So this much volume of blood perfusion, this much volume of ventilation. Many of you did that, but just that anatomical dead space is all this tubes and all that, part of the tidal volume that do not play a role in perfusion. They are not in the alveoli doing oxygen transport. They are elsewhere. But we do, of course, inhale and expire them, that part also. That is anatomical dead space. You have to subtract that. And this is, at least for some of you, directly from class notes. Okay. Assume that the ratio of total blood liters of Feynman. So this is blood liters. Again, I hope you didn't make a mistake here by body weight. I'm using blood liter by body weight as 0.07. So blood liter in a 70 kg person is 70 into 0.07. Hematocrit is 52%. That means volume of RBC liters, okay, is 70 into 0.07 into 0.52. What is left is plasma, or mostly it's RBC, 52%, or hematocrit. Even if you account for that, hematocrit says plasma and cells
cells is 52%, plasma is 48%. So answer you're looking for is 70 into 0.007, sorry, 0.7 into 0.48, that is 1 minus 5. I think again the answer key there is fine, 2.352. Fine. Yeah, this question, if you missed it in the exam, you have no excuse. Okay. Medical imaging directly from Princeton links. I also put some practice questions in YouTube. See, it's very hard to ask questions outside of this thing. So 64, 65 exactly from Princeton links, the practice questions that I gave. Okay. So I think movement and rotation. Time taken for movement, time taken for rotation. Now, for one projection, I mean, at one angle or one projection, movement is 0.5 meters. It could do that in 1 second at a speed of 0.5 meter per second. So 1 second into how many projections? 360. This is the time, seconds corresponding to movement, seconds corresponding to rotation. So one rotation takes, I suppose, 0.5 seconds. That into 360. So 360 plus half of 360, I suppose that is 540. Okay, that is fine. Here, if you miss this question, you are to blame. Anyone. Okay. Again, inverse square law is the same question. So no confusion with units, nothing also exposure, nothing with dose equivalent and all that. So, yeah, we have discussed this question quickly. I think this is fine. At 50 milliamps, you get an exposure at 0.75 meters. Want the same exposure. The current corresponding should be certainly higher. Specifically 1 by 0.75. Inverse square law, there's a square term here. This is MAS you are looking for. Okay, again, that is 88.89. Okay. So that comes to the end of this session. Hard looking questions, I'm sure most of you, oh, this is what they mean, this is how they obfuscated. I'm sure most of you would have learned that. Second, I told you all the problems here we discussed. Okay, but I have final parting words. That is, paper is hard, at least as hard as 2021. Okay, and I am expecting. So before my expectations, let me update my data. Anyone like to share how much you are kind of getting roughly? Let's say they don't anyone getting 40 plus? 38 would be a good score. Okay, great. Okay. So my expectation is last time All India rank 1 was 65. Might get lower. That's my expectation. 40 plus you might be a topper. When I say might get lower, I am saying 40 plus might be a topper. But there are outliers, 50, 55. I know some other outliers wouldn't show up. 50, 55, but 40 plus likely a topper. Okay. But which is where the important detail that I want to things. So things are hard. Okay, that one day something happens. There is a how much ever you prepare, there is this factor of luck. There are n number of reasons for which things don't work out. But there is one important takeaway there. Okay, so let me tell you 2 stories that most of you don't know about, because whether you are in my class or not, even students in my class don't know it. Anyone know who got All India rank 2 last year, 2021? That I mentored him and all that, you might know. Of course, my students know his name. Others, Abhishek Soni, heard of his name? Yeah, Abhishek Soni. Then All India rank 4 student I mentored, Madangi. You might also recall her name. So two interesting details about those two students. Both of them are amazing, hardworking students, very, very diligent. Okay. But luck was not necessarily on their side during the exam day. Okay. Abhishek, so this time I'm saying it might be close to 50s because students I mentored, actually many students did not tell me like what they are likely to get. After the exam, there was like a silence, so I understood, okay, perhaps paper was hard and or it was not their day, so I presumed that. Abhishek, as soon as exam was over, he told me, sir, I did not do well. Okay, that was his feeling. And the moment answer keys were out, suddenly he was like, sir, I'm getting around 59. I said, around 59, you are like a topper. You said you didn't do well. Yes, sir, I thought I didn't do well, but yeah, it turns out I had done well. So actually for Abhishek, 2021 paper was very hard. That was his perception. So our perceptions are somewhat distorted. Okay, we feel hard, we feel easy, somewhat distorted. So don't give a lot of thought to that. And the point there is, if it was hard for everyone. Okay, that's a fair part about the exam. And don't give a lot of weightage to the, how you felt right now. But let me come to the most important detail and then we'll wind up. I'll take 1 or 2 more minutes. Okay, I'm not going to waste a lot of time, both yours and mine. Second story about Madangi. So Madangi, actually, it was her second attempt. Do you know her rank in the first attempt, any of you? 2020, she gave GATE exam. 2021 was her second attempt. She got All India rank 2 in 2021. Anyone knows her 2020 rank? Yes. Okay. Again, due to lack of time, let me help you. Around 50, I think, and that's what I heard from my staffs. Okay. Now, what I heard from Madangi is she did not clear. It might come as a surprise, but what I heard is she did not clear. Okay. So she did not have a rank. She scored around 22, I think. But the takeaway is okay, so join the mentoring program, prepare and write again. That's not the takeaway point. During her exam, she was looking at things. She was prepared with medical imaging, bioinstrumentation, in and out, left and right, everything. She was prepared, perfectly prepared for Yorkers. Suddenly the bowler comes and bowls, bouncers. Off guard, you're off guard. So she felt like that. Because there were no, she was searching for medical imaging questions, hardly spot any. There were medical imaging questions, or she was searching for biomedical questions, but hardly any in the paper. Mostly signals and systems, control systems, all out of syllabus question and all are spotting her high. So this is what she told me. For a moment, she thought, oh my God, 2020 is repeating again. What if I don't clear again this year? She got into that state. Okay. Then what happened is she pulled herself back. This is during the examination. Okay, no one is there to help there. Okay, all the help happens before the examination. She pulled herself back with this thought. Okay, paper is hard. Okay, even if I am going down, let me give a good fight and then go down. So she thought she may not clear again. The initial 45 minutes, she gave a good fight. After 3 hours, of course, she got All India rank 4. The takeaway point is things are hard. GATE paper is hard. One is okay, fairly hard for everyone, but things are hard, not just the GATE paper. GATE paper, okay, GATE exam is hard, man. I'll look for some other option.
that option is going to be hard. Okay, life is hard. So the best hyperbolic situation here is, okay, I want to become a sannyasi, that I want, things are all hard. I want to like live light and go to forest and live. Going and living in a forest is very hard, because there is one more person fighting for the tree, one tree that has a spot for, night stay. That also is a sannyasi, but is fighting for that cave or tree, and there is one spot and you are still fighting. That fight is also hard. So even if you give up everything, go to a forest, things are going to be hard. Okay. So not just the GATE exam. Life, any good thing is hard. What makes difference is how you deal with that hard. Okay. How you face it. That's a second takeaway point. Whether you clear it, get all India rank, one single digit, don't clear it, whether you're going to give GATE exam again or not, none of that matters. Point is, things are going to be hard. Learn how to face it. Okay. Start seeing all this difficult things as learning opportunities. Okay. And then all of a sudden things start, working on your favor. All of a sudden, luck starts playing to your favor. So again, two strong takeaway points from, two personal experiences that I have, very close personal experiences. So, face things bravely. Whatever GATE is just an exam, man. So, of course, there are a lot of YouTube videos on this, but, face things bravely. Okay, things are going to be hard. Develop the mindset, see what you can learn, how well you can face, what good of fight you could put. Okay. So with that, I think this is good. So few questions. What will be the clearing cutoff? Certainly 25. It doesn't go below 25. Certainly 25. And of course, there is this minor variation based on what kind of what category you are in and all that. But certainly 25. Okay. I was thinking perhaps it might go to 27 and all that before the paper. After the paper, likely to remain at 25. Top 50-55 is what my expectation is, considering outliers outside of students I mentored. Okay, someone comes and takes 60-65, of course that's possible. There are good institutes outside. I mean, not coaching institutes, institutes outside. Possible. There are good students outside. So again, that's my guess, expectation. And then one more question: can we get any rank versus mock details per BM paper? Yes, 2021 we have a nice list of rank. I can share that. And of course, all these issues we can discuss. Off late we can have a separate discussion on this. So not an issue. And also, once the marks are out, I will also curate ranks and scores. I'll get some data points so that we'll get to know where we stand, what are our chances of getting a seat and all that. I'll curate that. Usually do that every year. So I'll keep doing that. Okay. So I'll keep the community posts active. Okay. 2 or 3 students are interested in the questions that I post. If you respond, if 2 or 3 are interested, I'll keep posting throughout the year. Okay. So I was trying to do this in Facebook, WhatsApp. Someone asked me, is there a WhatsApp group? I tried all that, doesn't work. YouTube is convenient for me. I'll post questions, interesting questions, keep posting that. Okay. Many of you came here because of those posts, right? I advertised this meeting on that post. I'll keep doing that. Okay. There is at least 2 or 3 students following it. I'll keep on doing. Okay, then let's stop here. Rest of the things, of course, we can catch up offline. Have a good one. And yeah, I hope you had a nice time. So those who stayed till started with 18, kind of like that, 6 students, that is good. So this is, I don't know if you've seen this videos from Mr. Beast and all that. Life is like this. This last person to take hand of the car gets 1 million, right? So last person to give up get preparation gets first rank. So things are like that. Last person to leave the discussion, gets a more, something like that. Things are all, there. I'm glad those who stayed here right now, 6 of you, that you stayed.
So yeah, decide to do something, do it diligently, man. Do it. You decided to do it, so just give it your all. That I'll see you again. Hope you had a nice time. Okay, someone has can you quickly enlist with questions or what challenging? Yeah, very quickly. I think this will be challenged. The key will be changed. Okay, there is a mistake there. It is not worth it, man. They are clear about what they do. Again, not worth it. This is yeah, get a definition, nice definition, it's worth it. Without a definition, it's not going anywhere. I can take a look at this. Systolic detail, I can take a look and confirm. Yeah, we have to be careful about the limits. 0 plus 0 minus 0. This one detail, if you're sure, I need to slightly go verify what g of 0. Essentially, what happens at the limit? If this term needs to be retained for what they are asking, it's worth challenging. Okay, again, needs some confirmation. So this again, no man, this is keep things simple, not worth challenging. So the reason I'm saying is last time they made a mistake with this cardiac output measurement, thermodilution. I wrote a nice challenge, okay, which they didn't bother to take a look at it. Perhaps they said, okay, there is a mistake, so what? I'm going to stick with my mistake, and they don't give you any response, so you don't know what happens. It's not worth it. This is certainly worth challenging. 48 should be MTA. Units are not given, man. Challenge it. I'll sponsor this. Just say in which units. 2 decimal places in which units. That's a challenge. So I can sponsor this. Okay. We need to verify these to 55, 46, but I suppose they are correct. Okay. Which relation do I use? You are not. If you are referring to C-clamp meter, you are referring to Faraday's law. Then what do you mean by Hall effect? And you are not given the relation. Then how do you expect me to get the right relation? Challenge this. And yeah, I think we had a quick list. Okay, sounds good. Okay, it's getting off. A couple of some people are waiting for me here, so let's take off. Have a good one. Bye. Okay. So yeah, have a good one.